All right, the last part of this, shock and such. When you don't have the appropriate fluids moving through the tissues, inadequate tissue perfusion. With no oxygen, cells can't make enough ATP. They try and they go anaerobic. That means they're running without oxygen. And the end result are organic acids, the key one being lactic acid. As that accumulates, the pH drops, and then bad things start to happen when you lower that pH. There's types of shock. Hypovolemic, you're running out of blood. You got a leak somewhere. Cardiogenic, the heart's not pumping. Vascular, something has happened and all of your blood vessels have dilated at the same time. That could be due to an allergic reaction. That could be due to a damage to the brain. That could be due to bacterial toxins. So you could have anaphylactic shock, you could have neurogenic shock, or you could have septic shock. Any one of those. Blood volumes, blood pressures not adequate because of loss of blood or blood pressure just too low. When blood pressure, this whole thing works off of blood pressure. And when blood pressure drops too low, things just don't work. There's another one there, obstructive shock, and that is a block in the cardiovascular system. So that could be an embolism or a cardiac tamponade. Something's blocking the flow of blood into the heart, if you will. Now there's types of shock. There is a compensated, and we'll flip here. There's a decompensated, and then there is irreversible. In a compensated, you can do things and the body will respond. You can compensate for this. The body does this so that you don't die, if you will. Usually you haven't lost that much blood, 10%. So think 500 mils. That's a stinking lot of blood. It'll make a mess, but your body's able to, through a negative feedback system, restore the balance that it needs to. So you can read through there. If you have a decreased blood flow going to the kidneys, that RAS system kicks in. With the production of angiotensin II, you have vasoconstriction, and then the release of aldosterone. You have sodium reabsorption and water reabsorption and potassium reabsorption. That also you'll have a release of ADH, so urine formation is lessened. Then you'll get sympathetic impulses because the blood pressure is dropped. You'll get sympathetic impulses, which will cause vasoconstriction, especially to the skin and the guts, if you will. Increase in the heart rate, and the heart pumps up harder. So, in an area that might have been deprived of oxygen and such, then that by doing all of this, that pushes the blood into those areas, getting oxygen returned to them, lessening the effects of lactic acid and such. So the body takes care of itself. Decompensated or progressive. Now you have to have some sort of medical intervention because this sets off a positive feedback. You've lost upwards of 20% of your blood volume. You've lost a quart of blood. That is a lot of blood. When that happens, it can actually slow your heart down because it's not getting oxygen and such. You'll go into bradycardia. That, since it's not pumping as much and it's not pumping as strong, leads to further hypoxia. And it's just a positive feedback. Things get worse and worse. That less flow of blood to the brain, right? And then that no longer works. So then the blood vessels start to just dilate. You lose that vasoconstriction, if you will. The capillaries then become leaky. All of them become leaky, and the blood starts to go into the interstitial space, not in the vessels and such. The blood slows down. You start getting clots. Things start to die. Acidosis increases. If you don't find the loss where it's leaking and you don't put the volume back in, bad things happen. You can turn this one around. Okay, it's dangerous. You can turn this one around. Such. Irreversible. Something has happened the heart, something, a pulmonary embolism, something, and no matter what you do, you can't stop it. And the heart just runs out of energy, and so it's over. Try as you will, it's just over. It's irreversible. So uh, usually that progressive leads to this if you don't get the medical intervention in time. How do you know a person is going into shock or in shock? Low blood pressure. That's the first way right there. Feel of their skin. Remember, the blood is not flowing to the skin, so feel of the skin. You can feel that as such. You can see that. Epinephrine is flowing through the body, though, so you're going to have sweating. You're going to see that occurring as such. The amount of urine that they would normally produce, they're not producing. They're not alert. There's not enough blood flow to the brain. They're not alert. Then you can measure the acidosis and such. Feel of the heart rate. Take a pulse. Fast, rapid heart rate and such right there. That's tachycardia. It's a sign of shock. It's not a strong beat. It's a weak beat and such because the blood vessels are all dilated. They're thirsty. They ask for something to drink. They're thirsty and such, and yet they are nauseous because there's no blood flowing to the digestive system. They're going to feel this nausea, So those are your signs of shock. All right, we're going to leave it right there. You can read the rest of the notes and such, and you can figure that out. We'll do the fetal circulation routes when we do embryology in the lab and such, but the rest of that you can read and follow, and it kind of goes with the lab. So I'll leave it to you.